Today I'm going to be giving a little bit of a summary for most of the things that we've heard about today in terms of harvest weed seed control. And I guess the starting point is really why are we so interested in harvest weed seed control, and we've heard a bit about this as well. So this is a map of New South Wales, which represents the northern range for annual ryegrass populations at the moment. At least populations that can be randomly collected in a survey. So the dots here are randomly collected annual ryegrass populations, survey conducted in 2016, which was a good year for weed seed collection. The red dots are populations that are resistant to one or more herbicides. The green dots are susceptible populations. So that's fairly indicative and fairly depressing, I suppose, in terms of just what is happening with ryegrass populations in New South Wales in particular. That's not to say that there's no annual ryegrass in Queensland. There definitely is. Just at this stage it's at low enough frequency to not be detected through a random survey. Oops. So for wild oats, similar story. I should add, sorry, that 70% of populations, of randomly collected populations, are herbicide resistant. For wild oats, it's not quite as bad. Same survey, 40% of the populations are resistant to one or more herbicides. And there's a bit more of a concentration of the red dots in the north for wild oats. Okay, so herbicide resistance is the reason why we have to do something else. I guess the next question is, what can we do? So the first thing that we really need to know is, just in terms of harvest weed seed control, what proportion of that seed production can be collected during harvest. So this is a compilation of studies from Western Australia and from New South Wales and Queensland. So for wild oats, potentially you can get 70 to 93% of the total seed production. For the brassica species, so that's inclusive of wild radish, African turnip weed, etc., it's pretty high proportions can be collected during harvest. So they're a pretty easy target. For ryegrass, a lot of data now about seed collection potential for that species, so 68 to 90%, so that's pretty good as well. And south thistle, as Michael Widerick mentioned earlier, not so good, about 50%. Some of it does go through the front of the header during harvest though. We have got video footage to show that those seed heads can stay intact into the machine. Okay, so they're the potentials that we can get when we start targeting these weed seed populations. We need to think about then how we do it. So crop harvest, okay, it's all about collecting the grain. That's the target, the whole purpose of the exercise. But there's also another thing that's happening at crop harvest, and it's weed planting. So as the numbers say, there's lots of weed seeds go through the front of the harvester. During harvester, these weed seeds all come out the back here. And so they're not just dropped back on the ground, back where they came from, they're actually spread across the width of the comb, or supposedly across the width of the comb. So you're actually setting up your weed problem for subsequent years. Now, we've been doing this for a very long time, and you start to wonder why you actually do that. You wouldn't do it for another pest problem. You wouldn't do it for a disease or for a Russian weed aphid or anything like that. Why do we do it for weeds? Well, I guess maybe we shouldn't. So, okay, if we're convinced we need to do something, the next question is, what do we do? Well, we're fortunate, thanks to some innovative growers, that we have got quite a few options to choose from: chaff carts, chaff lining, tramlining, windrow burning, bale direct and impact mills. Okay, so now the decision is, we've decided to do something. What are we going to do? Let's think about, before that, let's think about what the impact is actually going to be. So these are numbers for annual ryegrass based on some trials that we did both in WA and across the eastern states a few years ago. We compared just a control, narrow windrow burning control, a chaff cart with a Harrington seed destructor. And what we found at each of those 25 sites, there's no difference in the effect of the different harvest weed seed control treatments on the subsequent emergence of annual ryegrass. So every harvest weed seed control treatment has the same impact on the ryegrass population, as long as you're getting your weed seed into the chaff fraction. So that's the critical part to these studies. As long as you've got your harvester set up so the weed seed's coming out in the chaff, then the chaff will be equally affected by whatever you do at the back here, whether it's a chaff cart, seed destructor or narrow windrow burn. So 60% reduction on average is what we found, but varied substantially from 30 to 90%. So where we had big populations of ryegrass, there's obviously a huge seed bank, so you only see a 30% reduction by what you do in just 1 year. Where you've got a low population density, a lot less in the seed bank, so you can have a big impact by just 1 year's effect of harvest weed seed control. Hopefully that makes sense. All right, so again, just wanted to re-emphasise this bit about getting the weed seeds into the chaff fraction. It's absolutely critical for all the harvest weed seed control techniques. You have to make sure that it's just straw coming out here and that you've just got all your chaff and your weed seeds coming out in this chaff fraction. Another critical part to most of these systems is you actually have to try and separate that chaff and straw fraction too. So we know that harvester setup means that you can get at least, well, 95% of ryegrass will come out the back in the chaff fraction when you get your setup right. Okay, so now going through the various systems. So chaff carts, you collect all the chaff material straight out the back of the harvester, you leave the piles of chaff around the paddock, and then you need to do something about them. And there's a range of options depending on whether you want to feed that material to stock or you just want to get rid of it to dispose of the weed seeds. It's a very good feed source, 12 to 14% protein depending on what you've been harvesting. There is an initial cost. A brand new chaff cart will cost up to $80,000. It's a trailing system, a lot of people don't like that, and there is some nutrient removal because you're concentrating that chaff material into certain areas of your paddock. Okay, so moving on to the Glenvar Bale Direct system, another Western Australian farmer development. So here all the chaff and straw material collected by a baler. I have these lovely stacks of bales left behind after harvest. The reason for this system coming into being was because it was a financial opportunity. So that means it's also market dependent. Good feed source, high initial cost, obviously with a baler and this hydraulic drive system here. Nutrient removal, so there is nutrient removal based on all the straw and chaff materials being taken away from the paddock. So those nutrients need to be replaced. So narrow windrow burning. Again, these are systems, as I'm going through them, are the chronological order that they came into being, if you like, the order in which they were developed. So the narrow windrow burning was at the time the opposite end of the spectrum for the Bale Direct system. Very cheap, just a couple $100 for a chute at the back of the harvester. Pretty easy to set up at harvest. You've got all the chaff and the straw material set up there. Basically it's just putting the fuel source around the weed seeds. And you come back in autumn and you burn those chaff windrows, burn those windrows to just destroy the weed seeds. As I said, cheap, particularly suited to non-cereals. Obviously there's a fire risk, which we've heard a bit about today, but again, high nutrient removal. So all the nutrients are being concentrated into those narrow bands. Okay, so moving on to chaff tramlining. It can be a chaff deck or it can be something a lot simpler. So again, cheap. The beauty of this system compared to the ones that have previously been developed is that there's no additional operations. So once you've set these lines up at harvest, that's it. You leave them there. I've heard about reduced dust. There is some weed emergence. Warwick showed quite a lot of tram lines where there's weeds and there's crop grain that have merged. Some nutrient removal, so it's similar to the chaff cart in that respect. But I guess the big winner for a lot of people is just no additional operations. Similarly, chaff lining, so that's the concentration in the middle of the harvest at this time of all the chaff material, so you want a narrow band of chaff. Again, it's very cheap. Most growers just make up something with bits and pieces of material lying around the farm. There is some weed emergence again on those narrow rows. Nutrient removal also, and one of the downsides potentially is that residue build-up. It can build up over time. The rotting doesn't happen as quickly as we'd like. Okay, then the final ones to come along are the impact mills. We've got a few now. So this is the original seed destructor, the integrated seed destructor and the seed terminator. Again, no additional operations after harvest. The difference between this one and the others is that all residues are retained in the field. So everything that goes through the harvester goes back onto the spread across the paddock. High initial cost, horsepower requirement, so there's more of a running cost if you like, and an additional maintenance. Okay, so that's the systems in a nutshell. So I guess the message there is choose one that you think fits best with your production system. They all are, as I said, equally effective. The next part of the story is what's the long-term impact of these systems. So this is a study that Peter Newman started back in 2001. It's a long-term paddock monitoring study, which now Bonnie Jupp has taken over from the department in WA. So over 17 years, these 25 paddocks have had the annual ryegrass populations monitored every year in August, just to look at the populations that are present after all the in-crop treatments have been imposed. So of those 25 paddocks, there were 13 that used herbicides alone to control annual ryegrass. And I should add that at the start of this study, they were all problem paddocks. They had blowouts, if you like, of annual ryegrass populations. So 12 or 13 of these blowout paddocks, very high levels of annual ryegrass, but the growers had enough herbicide resources remaining to be able to get these populations down to what we used to call an acceptable level of 5 to 10 plants per metre squared. So that's 5 to 10 plants per metre squared at anthesis. Another 12 paddocks used the same herbicide practices, but they used harvest weed seed control, and from about 2008 onwards, the population densities are less than 1 plant per metre squared. So the interesting thing for these paddocks was that they were using harvest weed seed control techniques every second or third year. It wasn't every crop every year. So that's the impact that you can have when you're using these systems just 50% of the time or just 30% of the time. And that is really where we need to be in terms of the future of cropping, particularly when you start thinking about sustaining your herbicide use. All right, just to put a little bit more perspective on it, if you translate those numbers into seed production now, so the same plants, this is the amount of seed production that you're going to get over time for these same systems. So for just the herbicide alone treatments, it's 1 to 2,000 seed per metre squared going into the seed bank from 5 to 10 plants. less than 1 plant per metre squared produces 1 to 200 seed per metre squared going into the seed bank. So there's an order of magnitude difference in the problems that you're going to subsequently have just by going from 1 plant per metre squared up to 5 to 10 plants per metre squared. So that really is where your future impact lies with the use of harvest weed seed control. So this is all about the adoption and use of harvest weed seed control now by Australian growers. And it's good, I think, for us to just remind ourselves that this is an Australian innovation. So this is something that's not been developed elsewhere in the world and delivered to us or forced on us, if you like. This is something that we've done and that we've adopted now on quite a large scale. So 43% of Australian growers are now using some form of harvest weed seed control. This study was done in 2014. I suspect that these numbers have probably changed somewhat. Narrow windrow burning may not have gone up, may have gone down, but definitely chaff tramlining and chaff lining, which is not included in this study, have gone up. The important thing is that 80% of growers at that time expected to be using some form of harvest weed seed control by 2020. And I think that's reasonably accurate. There's definitely a lot of interest in these systems now, and we keep getting new systems coming forward, which is fantastic, and they keep getting better. So I think it's a testament to Australian innovation and Australian farmer innovation that we're seeing this happen before our eyes. It's not every day that a new weed control technology gets through to market. Okay, so the question is, if you're going to adopt a harvest weed seed control system, which one? The other thing to keep in mind though, weed control is all about compromise. None of these systems are perfect. In fact, they're all pretty much flawed one way or another. The problem is that herbicides have been so good for so long that we're sort of forced into using these systems now, and we're going to have to accept compromises. Okay, and I think I'll leave it at that.